Welcome to Computer Engineering Analysis Lab. As a problem, we are going to solve this analysis of beams, that is SFD BMD, that means shear force and bending moment diagram drawing for this simply supported beam, which is loaded with only point loads as shown in the figure. So Young's modulus is given and Poisson's ratio is given. Okay, so let us start the Ansys Workbench. So in that, let us go to static structural. So in that, engineering data will go. So we'll change it to megapascal. So 200 megapascal is nothing but 200 gigapascal is given in the problem. When you convert into megapascal, it will be 200 into 10 to the power of 3, whereas Poisson's ratio is 0.3. Now we will move to the geometry. In geometry, you need to create uh, the whole length of the beam, that is 1.5, 1.5 and 1. So the geometry window has opened now. So let us draw the line. So in order to draw the line, click the line button and click the origin, and first 1500 mm, that is 1.5 meter. Type 1500, press enter. One thousand five hundred, and again 1500, again 1000. So when you fit so you can check that there will be 3 elements. Okay, now what you need to do is go to prepare. So just you have now created 3 lines. Now we need to assign a proper the cross section for this. Okay, for that we'll take a cross section which is given 30 into 20. So we can edit this rectangle, right click, edit beam profile. So we can go to edit and go to click on breadth. So breadth should be 30 and height should be and height should be 20. Now after completing this, close this SYS option. So once you have completed this, now press escape. So the click on the beam element and click on the rectangle so that it will be the area will be assigned to this element. Again go for clicking this and rectangle. Same thing you have to do for all the. So once everything is finished, go to structure, design, share topology. You go for share, then close this window. So now geometry has been completed. Now go to model. So double click on model. You will going to see. So it will take few seconds. Okay. After that, model window will open. Once the model window is opened, so you will see the whole entire beam. So you need to fix it. You need to apply the boundary conditions, two boundary conditions, that is simply supported boundary conditions at the both ends of the beam. Okay. Then you need to apply the loads. Two loads. One is 20 kilonewton and another one is 40 kilonewton. Okay. Now when it appears, you go to the mesh and right click and generate mesh. So this everything will be converted into mesh. Okay. So this is our beam. Now we need to apply the load. First we'll apply the load. Right click on static structural, insert force. Okay. So you can check, first one is 20 kilonewton. So you need to apply the load on the vertex. So check for the vertex. So if you find here, okay. So after you type the then vector, you replace by components. Okay, then afterwards you need to apply y direction, that is minus 20,000. Okay, same thing you need to do right click, insert, force, y direction minus 40,000 kilovolt, 40,000 newtons. So we have applied the loads. So if you want to see whether the applied load correctly or not, it is visible here. So B is 20,000 and A is 40,000. Okay. Now we need to apply boundary conditions here and here. So for that, one option is there called as remote displacement. So you need to use the remote displacement as the option. Okay, once you click on remote displacement, again vertex you have to select this vertex. Okay, so here everything we have to select and put 0. Okay, so y component also 0, z component also 0, rotation x 0, rotation y 0. Okay, now on the other end you apply the remote displacement. Okay, here x will be free because it's a simply supported, that is a roller support. So remaining all will be same. So now the boundary conditions have been applied. Now let us go for right click, insert. We need shear force bending moment diagram. So we need to go for beam results, that is the shear moment diagram. So shear moment diagram, it will ask for path. You need to create a path. How you will create the path? Go to model, insert, construction geometry and path. Okay, so now path, when creating there are two options. One is by 2 points and another one is by edge. So you select edge option. Okay, starting from, then you select here the edge. Okay, click on this plus, and click on this plus. Okay, so 1 to 2 you have created the path. So now here come back to total shear moment diagram. So here you select the path as path. Okay, now you have created the path. So now solution, right click, solve. If you give, it will try to solve. So after a few seconds it has solved. Now go to the total shear moment diagram. So this is how you draw the shear force and bending moment diagram. Thank you.